Hello everybody, welcome to the Chapter 1 review video. In this video I just went back and looked at your Chapter 1 test, picked some problems that I thought were kind of mirrored what you'd be seeing on your final, and was going to go over the process and how to solve for them. So the first one comes to you from Chapter 1. It's a plain old solve for x. So we're drawing on what we know about how we can solve for x using the distributive property, combining like terms, getting x to one side. So let's begin. With this one, first thing we're going to do is we're going to look at simplifying the left-hand side and then the right-hand side. So 5 stays the same, minus, we have a 3x, and the negative 3 times negative 2 gives us a positive 6, equal to negative 5x plus 8. So now we're interested in getting all of our x's onto one side. If you look to our right side, you see that we have that negative 5x. So I'm going to get rid of him by adding a 5x to both sides. And I'm also going to combine like terms now on my left-hand side. We've got a positive 5 and a positive 6, which gives me a positive 11. And now we're going to have our plus 2x is equal to 8. Then I'm going to take and subtract my 11 from both sides. Remember, I'm trying to get x by itself. So this will leave me with 2x is equal to negative 3. Finally, I can divide both sides by 2. And we get x, and you can leave it as a fraction, or you could write negative 1.5. So our answer again is negative 1.5 for x. Hopefully this is something that's coming pretty easy to you now. Was a good warm-up, and now you're ready to solve for x. Remember, in this one, our x is just to the first power. We don't have any exponents, nothing crazy really going on, just solving for x. Moving on, they asked us to calculate the x and y intercepts for 3x plus 5y equals 18. It says to show your work and explain your thinking clearly. So I see this and I see that we have x to the first power. So really what we have is a linear function. It's just written a little bit differently than the way we like to see it. So maybe one thing you can do is you're like, well, this would be a lot easier if it was written in our slope form. So if we've got y equals mx plus b. So one strategy is to rewrite this formula, which we can do. We can subtract 3x from both sides. We've got 5y equals negative 3x plus 18. I did that to keep my x in the right spot. I'm going to divide everything by 5. And we'll get not so nice of numbers, but we'll get negative 3/5 times x plus 18 over 5, which I'm just going to leave as 18 over 5. Once I have it in this form, maybe what I want to do is take it to my graphing calculator. Graphing calculator is a great resource. So, if I go to my graphing calculator, I'm looking to my y equals screen. Sorry, it looks like my calculator is freezing. Oh no. There we go. We're at my y equals screen, and I'm going to take and plug that in. Now you can leave it as a fraction, but really it's just negative 3 divided by 5 times x, and then plus 18 divided by 5. We can take and we can go ahead and graph this and see that linear function that's going to occur. Your calculator is great. It has a lot of great tools for us to use. One of them is it can calculate intercepts. If we go to second trace, I'm looking at an intersection. That works when we have an equation plugged in, minimum, maximum, zeros. So I'm interested in finding, one of them is I believe our x-intercepts. So if I calculate a value, I know my x-intercept is going to, or my y-intercept should be where my x is 0. So that should be our 18 divided by 5, which gives us 3.6. So, going back, one of our intercepts that we can see on the graph is we know that our y-intercept occurs at 0, 3.6. And we're also interested in any x-intercepts. So any place where we would intersect with our x-axes. If we look back at our calculator, we can see that point. I'm going to plug into my y equals. I'm interested in what happens when y is equal to 0. And then I'm going to find the intersection of those 2 points. And it'll be able to give me another great tool we could use is if we wanted to look over at our table. You can kind of see up there the table functions given to us. And I can see if I scroll down to 6, when x is 6, y is 0. So another great tool is our table. So looking at the table, I can find that intersection point also. So that's going to be at 6, 0. So let me go back and double check it with that method I was showing you in your calculator. So we have 2 equations. We have the equation we put into intercept form, and we also have y equals 0. So we're interested in that intersection point. So if I go to second and then trace, I'm interested in finding an intersection. That's our 5th option. And then I'm going to bring my cursor down. Right now it's on that, we're talking about my first equation, that blue line. So I'm going to get it as close to that red line as I can. Hit enter. And then with my red line, I'm going to get it as close to that blue line as I think I can. Hit enter. We'll hit enter again, and we'll see that we have an intersection at the point 6, 0, which we found using our table the first time around. So that's how we can use our table to find x, or our calculators to find x's and y intercepts. All right. So to show your work and explain your thinking, another way we can do this is now that we have our equation, think about what an x-intercept is and what a y-intercept is. Well, a y-intercept is whenever our x is 0, so we're going to plug 0 in for x. So we can say y is equal to negative 3/5 times 0 plus our intercept, which we're calling b. Oh no, I'm sorry. My bad. Plus that 18/5, which we discovered was 3.6. So when we plug that in, y is equal to 3.6. So we'll have our intercept at 0, 3.6. Another excellent way we can find our x-intercept, we know that's when y is equal to 0. So we'll set that same equation where we're trying to solve for x for 0. And when we subtract 3.6 from both sides, subtract 3.6 from both sides, negative 3.6 is equal to negative 3/5 x. When we take and divide both sides by negative 3/5, you'll find that x is equal to 6. So algebraically, if we have 6, 0, that's going to be our y-intercept, or sorry, our x-intercept. So those are some ways algebraically and also using our graphing calculator where we can find those things. Moving on to the next one, they want us to graph the function, and they've already given us into that beautiful form. So all I'm going to do is look for 8 on the graph. Oh, my scaling's not the best, so this is 7 and 8, so I plot that point, and then I have a rise of 1 and a run of 5. So I'm going to kind of work backwards. I'm going to go down 1 and to the left 5, 1, 2, 3, 4, 5, down 1 and to the left 5, and connected. So just being able to see that this 8 is our y-intercept, and our 1/5 is our slope. If you're ever getting stuck though, another great thing you can do is you can just start plugging in values. So we can start plugging in 0, 1, 2, 3, 4, whatever we want for x. And we can create a table that way and then plot those coordinate points. Another excellent way to graph something. Moving on, it says to make a table, complete a graph, and give a detailed description of the function. And so with this one, we're really going to focus on that detailed description. So with this one, the first thing that you might want to do is maybe make a table. For me, what I'm going to choose to do is put it into my graphing calculator because it's already solved for y, which makes it 1,000 times easier. So I'm going to go back to my y equals, clear both of those, and then we're looking at the square root of x minus 2, close parenthesis, and plus 3, I believe. And I'm going to go in front and just put a plus 3. Oops. So it doesn't go under that radical, and of course, I just got rid of that. X minus 2. There we go. So I've got my function put in there. I can take it to a graph and kind of see what that graph is going to look like. I have my table, so I can always go to a table. Scroll up and down. You can see that for anything greater than, looks like a 2, we're getting an error, which means it'll be undefined, which makes sense because if we plug in a number that's going to be less than 2, it's going to give us a negative value, and we know that we can't take the square root of a negative number without getting imaginary numbers. So we can take, and you could write down that table and then draw that graph so we can plot those points. You might want to choose some of the easier ones such as 2, 3, 3, 4, 6, 5 are some really good ones to use. And then you can plot those points on your graph. And again, your graph should look like, and then here's what we're talking about with our details, describing, well, what's really going on. So with this one, we can see that it's an exponential function. Whoops, that is not allowing me to write a detailed description on the side. So, oh yes it is. Exponential. We can talk about the domain and range. We said that for our domain, we know that we're looking for values that have to be greater than or equal to positive 2. Our range, we know our y has to be greater than or equal to 0. We can also see that we have an asymptote. That would be y is equal to 2. There's no lines of symmetry, so we can say it has no symmetry. So we've got, here I've got 1, 2, 3, 4, 5 different things listed. So I've already met my criteria. And those are the different things we're interested in talking about it. So again, our table, already in there, and our graph. So we can take our table, take those points, and then translate it onto a graph. I always suggest using your graphing calculator if you can. It's a great way to check your work and make sure you're doing it. Obviously, the thing that's going to set you up for success if you enter that equation in your calculator correctly. All right. Next, for Chapter 1, you're going to see things like evaluate each of the following. They're going to give you a function, and they're going to ask you to do a few things with this function. I picked one of the more difficult ones, and it says to find the values of x for which f of x is equal to 25. So f of x really represents your y, and what they're telling you is that y is equal to 25. So we know that 25 is equal to x minus 3 squared. So with that information, what I'm going to be interested in doing first is we're trying to solve for x. And we actually can see that we have a factoring thing going on. So first what we're going to do is FOIL. So when we FOIL, don't forget your middle term. We're going to get x squared minus 6x plus 9 equal to 25. For us, it's really easy to solve when everything is set to 0. So what we're going to do is subtract 25 from both sides. And we'll have a new quadratic. We'll have x squared minus 6x minus 16. And from there, we can take and factor it out. So if I'm using my Xbox method, and my x, the top is going to be my first term times my last term. So I'm going to have a negative 16x squared. And then the middle is going to be my bottom, which is a negative 6x. Trying to figure out what multiplies to negative 16x squared, and then what adds to negative 6x. So I know if I'm multiplying to a negative, I need a positive number and a negative number. And then it looks like we're dealing with a negative 8x and a positive 2x. So from there I can take it and put it into my box. We've got an x squared, a negative 16x, or sorry, a negative 16, and then our box we're looking at sorry, I had to pause the video there for a minute. So continuing on, we've got our x squared and our negative 16x, and then we're going to take that piece of our diamond, our x that we had to figure out, and we're going to plug them in. It doesn't matter which box they go in, but we know we have a positive 2x and a negative 8x. And we're interested in pulling out what they have in common. So over here, we know we can pull out a 2. On the bottom, we can pull out an x. Over here, pull out an x. And then down below, we're looking at a negative 8. And so when I put that together, I've got x plus 2, the quantity x plus 2 times the quantity x minus 8. And if this is set to 0, we're just going to set those two things to 0. And so we will find that x can either be negative 2 or a positive 8. Again, really the trick here is we knew that after we set it to 25, it would be a lot easier if we had set it equal to 0, and so we should subtract away that 25. All right. I believe this is our last problem from Chapter 1, talking about domain and range, which we talked about was going to be very prominent on the test, being able to find the domain and range for this relationship. So first one, let's define our domain. Domain really is talking about our x values. So what can our x values be? And we see that we really don't have any restrictions. If we're looking at this x number line, I can choose values no matter how far out I go. There's no real restrictions on it. So we know that we can go as far negative as we want. We want to be greater than or equal to. And we know that we could go on forever. So really we're sandwiched between infinity. We can go to the left for infinity and we can go to the right for infinity. Really all real numbers will work for this problem. Then we talk about our range, which is the output of our function or our y values. So with this we're interested in our y values. So we're looking at our y. So you can kind of see that we're not actually going to have any values that go too far negative. We're really stopping at, it looks like, negative 2. And then we look at our positives and we increase forever. So we're just looking for values for our y is going to be greater than or equal to, it looks like we actually never approach negative 2 because of the asymptote that exists. So I'm going to correct myself. We're not going to be, it's going to be y is greater than negative 2. And that will be our domain and range. So that concludes our Chapter 1 video. Again, I just went back to your Chapter 1 test, looked at some old problems, and picked the ones I thought were the best. Hopefully this makes your studying a little bit easier, a little bit smoother. It is worth it, again, to go back and practice those problems, the ones you got right and the ones you got wrong. All right. Happy studying. Have a nice weekend.